The atmosphere produces an amazing variety of weather, arguably none more disruptive in winter than freezing rain, which made news last week from Dallas to Memphis to Washington, D.C., and even parts of Pennsylvania. Freezing rain is often mentioned in the same breath as sleet, and though the two are different, both require the same general setup to form. I credit former Weatherworld personality Lee Grenzi with the most colorful explanation of how to make sleet and freezing rain. He says you need to make a warm air sandwich. In the case of the atmosphere, the two slices of bread are made of cold air with temperature at or below freezing. The sandwich stuff in the middle is warm air with temperatures above freezing. And instead of sitting on a plate or a table, this warm air sandwich sits on the ground. The most common way to make one of these warm air sandwiches is at a warmer stationary front where warm air runs up and over cold air. So you end up with a layer of relative warmth above a wedge of low-level chill. Here's what a warm air sandwich looks like from the side. Now on the bottom is the wedge of low-level cold air. Here's the intrusion of warm air on top of that cold air, and above that warm air it's cold again, cold enough for precipitation to form originally as snowflakes. The thicknesses of the warm air layer and the cold air on the bottom depend on where you are in the picture, and that helps explain the difference between sleet and freezing rain. Let's consider, for example, what happens to a snowflake that falls where the warm layer isn't too thick and there's lots of cold air below. When that flake falls through the warm layer and either partly or completely melts, then it falls through a fairly thick layer of cold and refreezes in the air into a tiny pellet of ice. That's sleet. Now, if we move to a part of the sandwich where the warm layer is thicker, then a falling snowflake totally melts. And when that drop falls through the low-level cold air, it doesn't refreeze in the air, but instead freezes when it hits the surface. That's freezing rain, a true ice storm. And let me walk you through the changes in the temperature pattern of the lowest 20,000 feet of the atmosphere earlier this week in Washington, D.C., where snow changed to sleet, then freezing rain, and finally plain rain. The horizontal axis here is temperature in Celsius. I've drawn the key number, 0 degrees, with a red line. The precipitation began as snow here on Sunday, and notice the temperature was below freezing at all levels. A few hours later, warm air started to come in aloft, just enough to partially melt those snowflakes. So at this time, it was sleeting. And as the warm layer thickened and warmed even more, falling snowflakes totally melted. The low-level cold air wasn't enough to freeze the drops in the air, so this produced freezing rain. And finally, by Monday morning, almost the entire lower atmosphere had warmed above freezing. This setup produced plain rain. Now, in reality, the transitions aren't always clean-cut. You can get mixed precipitation, for example, sleet mixing with snow or freezing rain, and cold air trapped in valleys, as often happens here in Pennsylvania, just makes the forecast all that more complex. Fred is back next to talk about some of these precipitation types in the extended forecast.